back. Can you hear me well? Okay, this presentation, the first slide itself already shown something. I purposely chose this slide. This is a flood risk map for this part of the world, Southeast Asia. And the color, the bluish, the more bluish it is, the more vulnerable that the area to flooding. But a good point to point out is something like Jakarta, we all know. The 2007 flood was the one ever, the worst one ever recorded in Jakarta. So 60% of the area was totally flooded, up to 45 meters of that. And Kampung Melayu was one of the worst hit things. Now, I will need, for this particular presentation, I try to focus myself on flood. Doing flood, that's one thing. And on the first place, as you see over here, the title itself, data-rich downscaling from the dynamic downscaling. Like I will focus on Jakarta itself. The data quality, sorry for saying this, I grew up in Jakarta as well. The data quality number one is not good. Even if you have the data, the record length may not be that long enough. Okay? So the question is, we still have to move on as to how to design the storm drainage system for instance. The intensity, duration, frequency curve is one of the design codes for storm drainage design. How to live with short data record length. And obviously, the data quality has to be short. Okay, so that's the focus of my study, how to find the proxy, in other words, substitute data when you have a short data set. So this is related to the climate change step. Okay. All right, this is the outline. I purposely put this over here in the parentheses because I don't have the time, even assuming that I'm strictly instructed by the chair, session chair. Stick to 15 minutes, so I will skip this one over here, but at the same time it's nice to mention about ensemble, regional planning model, is something whether we have to do that. Next thing would be, this is the focus of my study, I mean presentation today, to find proxy data for short data record length. Okay, okay, quickly over here again, this is the overall vulnerability index map. Again, the previous speaker from Philippines mentioned about the Philippines is quite vulnerable. And in this case, the vulnerability index map comprises of the various things from flood, drought, sea level rise, landslide, and cyclone. This particular area of Philippines, cyclone, in principle, we don't see that in something else. So the red color is okay. Now, here we have a few maps from that, the composition of the map. So the Philippines, as you see over here, that one of them is actually the most reddish color. Okay, the other part of Southeast Asia is not. Okay. Now, I will be focusing on the flood. So the card is my point of discussion. Okay. Okay, we'll skip this one here. Okay, flooding. Singapore did not escape from that. So we have the 2010, that was on the Green Sea shopping center area, Orchard Road. It was totally an embarrassment to the government of Singapore. Supposed to be, everything should be running fine, but it is not. So 3 years ago, the Orchard Road area was flooded up to this 1 meter. Well, again, somebody from Indonesia told me, sitting aside, and said, because there are too many information about Orchard Road. So that's the reason flooding in Orchard Road. Okay, now, this is the city of Jakarta. The metropolitan itself is the one bounded by the green color. But we all know that Jakarta has been expanding to the left, to the right, to the east, to the west, and all the way to the south, north, to the south. Okay, so this will all the way to Bogor side. Now, the original size of the Jakarta is about 700 square kilometers. Singapore is about that size. Now, and the whole catchment is about double of that, 1,500 square kilometers. Now, what we are seeing over here is the data I have in my hand. I 11 stations, those are highlighted in red. Now this is the rainfall station. Out of this 11 stations, 9 stations I have has a good quality data set of 15 years, and 2 stations with 22 years. Now, remember that when you're in this part of the world, when the urbanization takes place as if there's no tomorrow, literally moving on, progressing and progressing and progressing, expanding, expanding, and expanding. But the question is, how do you define this area? Let's assume, for the sake of discussion, we have very good data for the metropolitan of Jakarta. But once you start expanding all the way to here, where the data from? Unless you assume the data over there is the same as the data over here, homogeneous. Okay? So we all know it is not, particularly if you know the topography of Jakarta, this is quite hilly. The Bogor side is going up. Okay? This is very flat up there, and as a matter of fact, some places are lower than sea level, the mid-sea level. Okay? Now, what we want to do over here is following. The problem is still there, we want to expand. The question is, if you don't have a sufficiently long record length, what do you do? Okay? So there you go over here. This is what they call the regional frequency analysis. You look at the whole region, and you combine the data from this region, whatever data set you have. The record length is bigger and longer. But the question is, do we have sufficiently long data right now? Because we are thinking about going to look at the recent period of 100 years or longer. Okay? Now, this is where the climate change comes into picture. Okay? I'm focusing, as I said, I'm looking at the floods, focusing on flood. Now, again, here they will go over here, I'm looking at the proxy. The proxy meaning substitute in this case. Okay? So where they're coming from, the proxy data that come from the, I'm suggesting of one of them is coming from the downscale reanalysis data. Reanalysis data is supposed to be the perfect model result. Okay? Because it's using all the station data from all over the world. Yeah? But again, if it's part of the world, South Asia, you're lucky that you have data set such as in Kalimantan, for instance, because it's forest area, rainforest area, so you have to rely on the station data from somewhere else. Okay, so I simply have to go through this one here quickly. Go up as well. Okay. Now, in doing the downscaling for the Southeast Asian region, okay, what we do first of all, somewhere else is simply good. I'm talking about focusing on the Southeast Asia. I'm using the so-called WARF, the regional type model, weather, basis, and forecast. That's coming from US and as we said for research. So we have to calibrate or parameterize that model with some data. That data is another reanalysis data. Okay? We have the European one, the American one instead, and also the Japanese one, and so on. Anyway, just that kind of reanalysis data. Then this particular route is really nothing but calibration or parameterization of the model. Once the parameterization is being fine, calibration is being fine, then what you do is simply use the GCM global climate model, using that as the boundary forcing for that region, and take a look whether the result of WARF, which you do not calibrate anymore, see whether the data, the result of simulation is being fine. If they're being fine, the rest is quite smooth flowing. We simply use the GCM data as a boundary forcing for the future. There's nothing much you can do except you have to accept that the result. Because the calibration is doing fine, the validation is also acceptable, the future you simply have to accept it. Okay? And then the future, as far as the change of climate, is nothing but the model future and the model curve subtracting from the others is nothing but the signal, the climate signal. Okay? So anyway, what our institute in Singapore, the Tropical Marine Science Institute, we have integration to the project. The first one was completed in 2009, and the current one is finishing by the end of the year. So anyway, what I'm trying to show you over here is that we have done the downscaling of 3 different GCM over here. The CCSR from NCAR, the M5 from Max Planck, and the Japanese one, the medium resolution. scenario we focus is nothing but A1B, A2, and A1 and Y for circumstance. Altogether, 7 simulations. Downscale all the way to 2100. And so we are running quite a big job over here. The domain of interest, the mother domain, is all South Asia except Jaya of the that's what it is. So the domain over here is 30 by 30 kilometers to spatial resolution, but we massive that down to this particular domain because it was quite there. But that domain is have a spatial resolution of 10 by 10 kilometers. Of interest, of course, because it was so tiny, straight kilometers, roughly about 30 longitude and width, and the height is 1.5 kilometers. So if you do not downscale up to this point, typically you present it back to by one big point. Now, that's good to do that, but obviously you may not be able to see it, so that's what it's all about. We expect the data. Okay, the one I will be discussing, I will be using only this particular domain, the mother domain, 30 by 30 kilometers resolution. Okay. So we have done for discussion's sake, I'm using this the result from WARF, but I've done also from Presley that I have the vision model. Okay. Now, the first thing what you do, like the one was talking about, how do you compare whether you have done a good job or bad job? Okay. So the first thing is you have to look at the present climate. The present climate you have the data to compare with. Future is you have to live longer to wait and then compare. Okay. Now, comparison, first of all, overall, in the global macro picture, you're looking at the whole Southeast Asian region. So we got the data coming from different institutional opportunities, what is called gridded observational data. Okay. So from the CRU, this is from UK, Dynamical Downscaling, and then the other one from the University of Delaware, and so on and so forth. So we have the data coming from UK, USA, Germany, and Japan side. So the reason I'm focusing on this one over here, the next slide I will be showing you only from one of the, otherwise there are too many panels, maps to be shown that will confuse you rather than understand it. Okay, so I'll look at the CRU, the Kinetic Research Unit, and for this part of the work. So this is observed data, observed again, simulated. Okay. And this is the one we simulate for, driven by what is called the reanalysis data. European reanalysis coming from Amsterdam. So there you go, this is for temperature. The temperature on the right panel of the page the topography, as we all know, Sumatra is actually that mountain range, this is also from the South China side. Okay. And now, this is temperature, surface temperature is measured 2 meters off the ground. The fact of the matter that this is the mountain range, high ground, 2 meters above it, and then we go there to reason over here, the temperature is cooler than this. Okay? Yellow color versus red color is over here, the yellow color is. So in other words, the downscaling gives an added value. Okay? Because over here it's not being downscaled with CRU. Though you see yellow color, but it's not that pronounced because the resolution over here is 5, meaning 50 kilometers. 50 by 50 kilometers. Over here is 30 by 30 kilometers. Okay? So there's an added value to downscaling. That's as far as temperature is concerned. Now, again, the winds is the one bringing the rainfall. Okay? So, but you see again the color, the light will become gray. So you see, this is to be compared this unit to be compared with the observing. We don't use CRU, UDEL, and so forth because they don't have data for winds. They have only precipitation and temperature. And hence you have to rely on the reanalysis data for comparison. Yeah. Wind is not too bad, the temperature is not too bad as well. Observation for that's for the northeast monsoon, southwest monsoon is due to the August, you have to see it again. The way you look at it, when you look at some of these downscale result, essentially you have to be a little bit more like an artist. Look at the color distribution. That's it. Because we are using the same color scale here and color bar and for both. So roughly the distribution is okay. Not like red color patches over here, then you have a blue color on that place. And so roughly that's the way you look at it. Okay. Now, next is precipitation. Precipitation is the most nested variable, most difficult part to do that. Okay. But now there you go over here. We have the dwarf result of TRU. TRU is supposed to have a heavy weight from there. We have only a few over here. The weight for that place is much more heavy than what it should be. Okay. So once you have done that, okay, I do the same thing with pressing, which I don't have time to go through for pressing. We have a redefined model. What I want to demonstrate to you is the following. It's useful to do the ensemble. The IPCC has recommended all along. Downscale as many GCM as possible. Downscale using as many RCM regional platforms as possible. And then ensemble. Since I can afford to do two things, WARF and pressing, I'm checking whether they're doing fine. Okay, remember this is nothing but a gradient observation data here. What I do is the following. I look at Manila. Okay. Okay. Now, okay, before that. Now, this is coming from the upper bound and lower bound from the gradient observation data out of the 5 here. Okay. So upper bound and lower bound among themselves, they differ quite significantly. It's rainfall. Look at the rainfall rate over here. It's supposed to be 18. The lower part is under 14 inches, 14 millimeter difference per day. Okay? So this is among the observation, gradient observation data set. Where's Manila observation data? Okay? Not bad. The annual cycle is correct. Okay? For the whole year, from January to December. Now, where are we from WARF? From WARF, driven by the analysis, not too bad at all. I mean, the cycle at least, I can accept that. Whether the discrepancy is big or small, that's secondary. First of all, the cycle has to be right, rather than the other way around. Observe this, the simulation is the other way around, and you're in trouble. Forget about the rest. Okay. So the comparison is not too bad. Where's pressing the other regional model? Driven by the same thing, the whole same domain. So pressing is underestimating for Manila that is. WARF overestimating some part, but much closer. Anyway, without giving bias of the one we have done with WARF, because WARF we can fine-tune them. Yeah, whereas pressing is not. It's given by the Hutchins Center for you to downscale it only. Yeah. If you do the ensemble, without giving bias to one to the others, over the others, giving 50-50 weightage, okay, not too bad. Yeah. So we do that for the other city as well. Anyways, okay? So that's the point, is the message to the audience that ensemble is not bad. It should be, if you can afford, do that. If you cannot afford, whatever you have to do. And quickly over here again. Okay. Yeah. Without too many animation. What you see over here is nothing but the ensemble from WARF driven by different GCM. But you see over here the final GCM is nothing, the ensemble one is nothing but the red color. Okay? And again, out of all the GCM, after you cut downscale, if you ensemble them, you get much better comparison. Okay? Similarly, next one over here, pressing, the same thing again. You do ensemble from the different GCM, it can represent the data CM3 to the much better one. So taking the ensemble from here and taking from the ensemble from there, that's what you learn next. Okay? Recommendation again, do that. Okay. All right, so we are done with the simulation of the RCM. Okay? RCM driven by greenhouse data. I'm back again to the question is project target. Yeah, we discussed that a little bit already. Okay, I'm looking at the regional frequency analysis. Okay. So we have night station data for 15 and 2 station data for 22 years. Okay. So since I don't know, remember that out of this 11 stations, only One is the met station, the meteorological station. Usually, you trust more on data or the data quality from the met station. The radio station, sometimes question. Okay? So what I will do is, the type of method that I know only one network station in Jakarta right here. Okay? I'm going back again to Singapore. Okay? Now we have 4 net stations data. We've got 70 stations, rainfall station, but I think only the net station coming from these 4 regions. Okay? Again, the data quality is supposed to be better than rainfall station. Right. Now I have 31 years. Don't ask why 31 years. So I pretend I have only 15 years. Actually, I have 31. I'm looking at only 15 years. Okay. So now what I do is the following. If I have only 15 years, I come up with the so-called IDF curve, intensity duration frequency curve, and then I compare that with the 15 years data set coming from observation. Okay. So what you see over here, without going through one by one, I know that we have to do bias correction. When you downscale something, you have an error, bias. So bias correction has to be done. Okay. So that's what we're doing over here. We have this regression coming from different period. So you have to do some bias correction for different period. Okay. So I'm using the 15 years, derive the idea, intensity duration frequency curve, and compare that with the intensity duration frequency curve derived from observation data. Okay. So once we have done that, now I have 31 years from the reanalysis data. Okay. I'm deriving the IDF curve from the 31 years from the reanalysis, and I'm adding that using the bias correction derived earlier, and try to compare that with the observation data. This is the station data. This is the log derived from the reanalysis of the bias correction, and then try to compare that. Look at the one over here. The error is between 10 to 15%. Okay. Now I do that for the other station over here. Okay. For 2 days, 3 days, and so on and so forth. The summary you should see over here is that between 10 and 15 days, 15% the error. Now, is it big or small? Well, we'll see. This is from USGS, Geological Survey. We have a rule of thumb. If you want to derive 100-year intermediate storm, you should have at least 115. The error rate under 15 days are record length. You will have about plus 10 minus 10%, plus minus 10%. So we are okay from that angle because we have 31 years for each station. So we have 4 stations. 31 times 4, we have 120 years. Okay. So anyway, this is only the rule of thumb. Again, asking for our part of the world to have 100 years is a tall order, even 25 years. Because the way we expand, urbanization is so rapid, forget about it in 25 years. Okay. Anyway, so regional climate analysis, regional frequency analysis, using downscale reanalysis data could be used for reanalysis, but could be used as proxy. Okay, coming back to one over here, the project cover is quickly over here. I'll do that without going through it. Okay. Now, the Jakarta February 2007 flood for different stations on the cone and so forth over here. Now, what you see, I don't think you can split that properly. For 1 day rainfall amount, it was about 339 millimeters for at least the first station. When you compare that, I cannot read that also over here. It's about 150-year return period for this particular station. For the other station, Allen, for instance, is about 98 return period, year return period. Okay. Anyway, so these are the one thing you could do. And again, for the 2 days, it was about 2 weeks rainfall from the south, the rain coming from here all the way running over to the other side. We thought that you are escaping the heavy rainfall, but the problem is heavy rainfall falls on the Bogor area, in the hilly area, the whole thing just rushed down, like what we said in the other area. receive the rain, heavy rain coming from here, but it goes up to the hill, the rain comes, the runoff coming on to the south. Yeah. So anyway, so this is one thing what we could do for that. Quickly also here with the 5 minutes, I will form things up the whole thing. We do this, it was a regional frequency analysis. The same thing if you want to do site-specific frequency analysis. Okay? So we do the same thing too. Okay? Now, quickly, without going through the detail here, there are several methodologies already available to do site-specific regional site-specific frequency analysis. What they do is following by looking at one here. These are my straightforward station here, my fingers. They are asking about something somewhere in between, within this domain. But if you're looking at the site outside of the station you have, they all fail. Nobody has that. Okay? So nobody has that methodology. I don't want to come up with another methodology which is in between. The point for discussion, this is exactly the same thing here. This is the idea of intensity duration frequency equation. You have to determine A, B, and C or D. This is intensity duration. Okay. So what this particular group in the Japanese DPRI, Disaster Prevention Institute, they come up with a contour line for parameter A, another map for contour line of parameter B and C and so forth. But you see that the red state inside the station I'm talking about, the one not known is here, the one with star. What they do for parameter A, for this unknown unreached side, they can just rotate between the contour line. That's just the idea is quite simple. But again, it has to be within this domain of the station covered. Okay? So if they all fail, regardless of whatever it is. So what we did from the again reanalysis data, we're looking at the 3 station data, the 3 math station data from Kuala Lumpur, Singapore math station, Kuala Lumpur math station, Singapore math station, and the Jakarta math station, which is this one here. We pretend that the Dhamaka station, which is about 100 kilometers away, is not available. And we do site-specific frequency analysis. Okay. So we did that, again, we are going through the detail. Okay. But finally, what we have is nothing but we have to bias correct by 30 to 45%. Okay. So the bias correction is the name of the game, we have to do that. Now, what we do is we compare, of course, after bias correction from the reanalysis data. So we compare with the available data set. Okay. So what you see over here, after you bias correct from the black one to the with the dash line, lower limit, upper limit, and then you compare that you plot the data coming from the station. Okay. Everything is falling within. I'm not too worried about this part of the year. Don't forget this upper limit is also an average of all of the data set. Okay. It's not outrageously sticking out like this the whole time. Okay. So we do that for the different periods. They all look like similar to this one. Okay, the future is straightforward thing. As I said, the delta factor, that's the name of the game. I will not go through that. But essentially what you do after you do the bias correction, you plot you add the delta signal. That will be your future idea for that particular site. And that's quite straightforward thing. Happened to be commercial time for this particular study. We got the best paper one where there is the highest. Yeah, one 2 minutes on that. Now, be careful one thing, that caution for you is the following. We use this for Peninsula Malaysia, we use this as to find the bias correction for this part of the world, or from Peninsula Malaysia. So we validate that with the 2 stations. One is outside, one is inside the domain. What the caution I want to do is tell the audience the following. Although you have a station close by here, we did not use this guy. The reason being is you have a mountain range there, this guy. So your psychological characteristic is different. So make sure you pick the right station for your bias correction study. Okay. So with that said, the summary is that very important is that for rainfall is if you have to do downscale. Some people is using the GCM rainfall data. Please don't do it. And of course you can get target. Yes. The temperature wind is okay. They are more homogeneous moving. Rainfall is, as you know, the western side of Singapore, even the small island, western part is very much from the east. Yeah. So, recommended by FPCC ensemble. If you can afford it, do it. That's quite good, that's ensemble. And then, again, my message is that if you have no data, think about using reanalysis downscale, underlying the word, the downscale reanalysis data as a proxy of your short bracket length or missing data value. Okay, with that, thank you very much.